into this whole big, that's probably a half a mile stream system. What do I mean when I say it was blown out? It was really eroded. There's garbage everywhere. There was no place to catch any of the trash that was coming in. There were trees falling down all over the place because so much water was coming in and undermining their roots. It was a bad situation. So we said, well, what forest cover type should we be looking at? What are the ecosystems and their partners? And what microclimate are we dealing with? I'll talk more about microclimate the next time we meet, but what are we dealing with on this site? How does it fit in the bigger picture? Well, we zoomed out a little bit in our analysis and realized that this stream connects to a very important system, that eventually goes down to the Occoquan. So we were like, yeah, we really, we got to spend some money and do this right. So what we ended up doing, this was such a cool project. You can see a little bit, this is new. This is on Random Hills Road, if you're ever in that area and want to take a look at it. It's, and these pictures are probably 10 years old. But we did a lot of raised areas. Oh, I'm going to hit you with some topo again. So we did the stream. We mimicked the natural conditions, which is a back and forth kind of stream, right? That's natural for this is coastal plain also. So that's how we graded it. And then we put in, purposefully, some high spots, some hills on each side. Some of them connected back to the shore. And planted those with trees that we knew would do well. Sycamore, red maple, things that we knew were in that forest that we wanted to duplicate. And I mean, as far as I know, I haven't been down there recently. This is a very successful project. It regenerated what was there. You know why the developer was totally down with doing this, even though it was hugely expensive? It looked ugly. Trees are all falling down. It looked crappy. And he's building these, $500,000 townhouses, and he wanted a trail system. So we said, okay, let's do a trail system that's part of this too. Because to sell stuff, it's got to have an environmental benefit, but it's got to have a human benefit too, to get somebody to pay for it and make it happen. So just really fun to be a part of such a cool project and get to spend lots of developer money. That was fun. But to really do something on the ground that really made a difference to regenerate the qualities on that site was great. Okay, so what's coming up? We are right on time. Oh, shoot. We'll leave that up for a second. The other elements that come under environmental site design, we talked about this, managing stormwater, microscale. Use improved erosion and sediment controls. Do you know that a silt fence, do you know what a silt fence is? It's a black fabric that they try to, is there even any on this development site? There is not. They try to hold back the soil. So like all this over here is disturbed, it's all bare ground. And then they put this fabric and you're supposed to dig it into the ground. And the fabric is supposed to stop the soil from going off the site. How efficient is that designed to be? Not very. I forget the percentage, but it's something like, only 50% of the soil is it designed to hold back, because it's just a woven fabric. I've seen, soil, sediment, I should say, small fine particles go right through it. So it's not a very strong method. But what could you do to hold that soil in place instead of just cutting everything down and putting up that fabric fence? What could you do instead? Did I hear trees? Yes! Save the trees. Save the trees. And what's a really effective technique is to do a berm instead. That's so much more effective. So you come along, here's your tree line, and you're going to build houses over here. Right along this edge, you've got to put in some kind of a barrier to separate the two. So the best method that I've seen is a little berm just raised up that's seeded with grass seed so that it stabilizes it, and then that just gets graded out at the end. Keep it off the tree roots and you're good to go. So there's lots of ways to improve on the current erosion and sediment control methods, and that's one of the elements of environmental site design. Keep the biomass on site. Whatever you cut down, chip it, leave it there. That's how we spread disease in trees and invasive plants. Just chip it, anything that you get on site, and keep it on site. You can use it for 100 different things, especially during a construction project. Use various land conservation methods. Maintenance agreements, really important. We've been using conservation easements a lot in the last 10 years. If you have a stream buffer on your property, it's got to be in a conservation easement. Okay, so that's part of how that works. And of course, stewardship programs like Friends groups and watershed organizations, definitely part of environmental site design, because people think that these structures don't need any maintenance, and they do. You've got to pick up the trash, for one thing, replace some plants every now and then, but it's like 1/10 of the maintenance of mowing a whole big stormwater management pond. Think about that. Grass gets cut about 17, do you do any turf maintenance? So how many rotations do you do in a season?
26 weeks, I think it is.
We used to do 17 mows in a summer. So if it's getting mowed 17 to 26 times, what? All of that gas and the fuel and pollution and all that stuff, versus a couple of times a year you have to go out and take a look at it, maybe refresh the mulch. It's no comparison. But everybody complains about how much maintenance these things take. It just, it's like opposite world. Well, we're kind of living in opposite world, right? So, okay. So you gotta have friends organizations, homeowners associations, whoever's gonna maintain those areas has to be equipped and know what they're going to do. And that's mainly done through maintenance agreements with whoever is going to maintain it. So then we have, what's new? Well, stormwater regulations, I don't know where things are in Virginia. Are you moving to a more environmental site design kind of thing? Does anybody know? No? Okay. Because Maryland is pretty much out front in the whole country on this. We have the Chesapeake Bay on our shores, so we kind of have a responsibility in Maryland to do it. So things on the horizon, certainly stormwater management regulations are going to change in the coming years. The alphabet soup is about to get even more interesting. We've got WIPs, we've got TMDLs, and we've got MS4s. That's a lot of alphabets. A WIP is a watershed improvement, implementation, watershed, I forget what the I stands for. Implementation plan, watershed implementation plan. That's here on this graphic. So you start out with, yeah, we've got polluted water. We knew we had polluted water, right? Back when we did these maps, we said, yep, we've got polluted water. And one of the things that they did was they did a lot more sampling to put with this data to figure out, where are we? So you study what the sources of the pollution are. The EPA was on the verge of having a lot of these water quality regulations across the country. I don't know if that's going to continue. I seriously doubt it. But some places like Virginia might still look at, how can we do these implementation plans to improve water quality, get best practices out there, really start doing the implementation piece. So when there's this is total maximum daily load, TMDL. Now this is on the horizon for regulators, those kind of things. You don't really need to worry about it at the site scale, but I want you to know what it is when you hear it and you go, oh, I know what that is. It's a limit on the amount of pollution that a jurisdiction can dump into the waterway. That's the simplest way I can say it. So everybody gets a load limit. And they also call it a pollution diet, which I kind of like that nomenclature because I'm always on a pollution diet, right? So it's their limits. So for example, Prince George's County, we have two major river basins in our county. We have the Potomac Basin and the Patuxent Basin. The Anacostia is part of the Potomac Basin. So those basins got allotted limits. Okay, so for Prince George's County, Patuxent side, you have a nitrogen limit of 10,000 pounds, whatever it is. You have a limit. So then we have to look at what our land use is in that watershed and say, how much are we polluting already based on estimates and scientific wild guesses? It's like, okay, a single family house on a 5-acre lot, it produces X and we have 10,000 of those, so our pollution load is this. That's kind of the math that they went through on this and said, here's what our existing loads are and here's what our limit is. In some watersheds, we're already over the limit. So what are we going to do? In most watersheds, I should say, we're already over the limit. So we have to go back into these neighborhoods, these places where the water quality is so bad, we have to go in there. Oh, I forgot, we changed how this was. After much pressure, we changed those old maps to this new map. What's your just impression? We went from those two to these. Let me hold them both up. Just because I think it's interesting policy and how we went from that to this. See, the good range is on there now.
It's a little bit of green. Less red. More yellow.
Yes, less red, more yellow. We're studying at a larger scale, at a larger watershed scale. So this was 42 watersheds. This is, however many that is, 12. One of the things that we realized was that the science wasn't really good at the 42 watershed scale. The sample size was not large enough to delineate it at this scale. So we said, okay, let's back off and do, basically what we did was we said the data's not good to support this nesting doll, so we have to go up one. And what it showed was we did actually have one watershed that was in the good range. And far more that were in the pink is poor. So very poor, fair, and then good. So yeah, so it was interesting politics around this because my boss was like, I want it to show something that looks better. And I was like, okay. And I could do it with a scientific basis. That's why the only reason I was okay with doing it, because the science said we should back off a little bit because there weren't enough sample points. I was like, cool. So it's just interesting how things evolve.
What was the standard that you used for creating what was poor, what was?
It's a state standard. It's a level of nitrogen and phosphorus, basically in the water, based on samples, based on water samples.
How?
Still a puzzle.
Well, I guess who set the state standards? And how long ago was that? Are they updated or does it stay the same?
It's the
for you?
Maryland Biological Stream Survey, MBSS, Maryland Biological Stream Survey. They're the scientists that set up the rating program, as I understand it. So, yeah. So we obviously, we need to follow what the state was. Oh, the other reason why we did this is because our reporting to the state on our pollution diet, on our TMDL, followed these boundaries, these different boundaries, these larger boundaries. So we said, oh, well, our planning documents talk about intersectional, crossing bound, working with other agencies. We said, what we're reporting in our land use plan should match what we're reporting to the state for water quality. That almost never happens for a planning department and a Department of Public Works to come together and do stuff together. So that was pretty exciting that we were supporting their work in that way. So that's good stuff. Okay, so what else? Permit review processes. Almost every jurisdiction that you talk to says, the development community says, God, this permit process just takes forever. Everything, it takes forever. My prediction is in the future there's going to be more third-party certifications, so I would suggest you keep your finger on the pulse of that, because that's potential work. If they start, county agencies go, we just can't hire up, we can't get enough people, my prediction is they're going to do more of that. Carbon credits are coming, growth offsets, pollution trading. Still being talked about in the Chesapeake Bay. There's a lot of people who are against it because it's allowing you to, growth offset and pollution trading works like this. Let's say I'm in Arlington, and Arlington is above their maximum daily load, their limit. So I come in and I go, well, you know what, I really want to build that building right there. I'm sorry, you're over your limit. But I'll pay money, or I'll buy these growth offsets or pollution trading chips or whatever it ends up being. I'm not saying Virginia has this. Maryland is still even talking about it. But if I buy those chips, then I get to go ahead and pollute right here. Environmentalists have a problem with that because even though that money will go to restoring something somewhere else, it's the pollution here that's a problem. And the restoration does not necessarily, with those dollars, happen here. So that's kind of what we're facing in the future is, like DC, gosh, they want to get rid of the height limit in order to, increase density. Well, what are you going to do with that extra pollution? Are you going to have offsets? Are there, ways to deal with that?
Well, they started a stormwater credit trading program.
In DC?
They're working on that. I think this is the second year that it's going to be working, so they're still trying to figure out the market and how it's going to work. But they're doing it, and they're considering letting government, so like the Department of Transportation, with the district department, to also be able to play into that market, so that way they'll be able to buy those credits too and remove them from the system in the way that like they would be making it on the stormwater.
This is, I think, going to be a big part of the future because, rarely is there an environmental law that stops development. You always find a way to negotiate a solution. So, except maybe if it's, golden bear habitat or something that, has to be preserved. So that's, that's the hard part. Cool, good local example. All right, so where are we at here? Looks like, drainage exercises. Huh, so where are my drainage exercises? They are right there. Okay. Let's see, this is lunch, let me just see. Let's do this before lunch. Everybody okay to hang in for another 10, 15 minutes, go past noon a little? Okay. So you said you enjoyed doing this. Let's do it on a little bit smaller scale, okay? Because that's probably, for some of you, that's probably going to be where you'll be working. So, everybody take a full packet down to the next blue sheet. And there's lots of extras, so I'll collect them back here. We're going to do these together, so and get out your pencils, because we'll do these as a perpendicular thing again. do a little, as a cohort. Is that what you said? I like it. Yeah, so these are a little more the scale that you would be working at if you're doing residential stuff. It's also just good to get the feel for the land. So you have on exercise 1, you have an aerial and you have a topo. So get those in front of you. Okay, thank you. Okay. So we're not, we're not delineating watersheds here, because frankly, it's just too complicated. But we're gonna go in and look at a couple of houses, and you're gonna say like, we're gonna try to answer these questions about these 2 lots. So let's start with lot A. Can you see where lot A is on your drawing? Does anybody know what this is called when you have a long driveway that goes back to a lot in the back? Anybody know what that's called? What shape does it look like? Oh, it looks kind of like a frying pan. They're called flag lots. Is that the term you used? What do you
Oh,
use?
I was talking about the driveway itself. We call them a pipe stem.
Pipe stem, same thing.
Okay.
Yeah, pipe stem lot, right. So here's the road, and you go way back up in here, and then there's your client. That's your client's house, okay? So you have that right there. And make sure you're looking at the aerial. That's right there, okay. Offsite, so where is the offsite water coming from onto lot A? North, south, east, or west? North is at the top. So which way is the water flowing onto that property?
From the north and the west.
Okay, are you seeing that? You can keep these packets, by the way, so go ahead and draw on them. I think they're fun to play with. Okay, so it's coming from the north. So is that what you're seeing here? Perpendicular, perpendicular. Okay. So are you seeing how you would look at this on an individual lot basis? You'd be going, okay, there's water coming all the way down that hill, across my neighbor's across the other property, and onto this one. So this exercise is like what you would do when you first get a client. It's like, okay, I'm going to start looking at this stuff, or you start a project that you're working with, your work or whoever. You're like, let me go see what information I could find. So now you're seeing how the water's flowing. Is it coming fast or slow onto this property, do you think?
It's pretty fast. 'Cause it's
And,
steep.
and what makes you say that?
It's steep.
Right. So this part right here, very steep, very fast that water's coming down there. So when you go out to look at this house, you're going to make sure that you look at that steep slope. Is it stable? Does it have trees on it? Does it have trees on it now? Can you tell?
Not really, not from where the trees are,
On that
Below.
slope is what I mean.
yeah, I guess, yeah.
Yeah, it looks pretty wooded. What else might you want to know about that hill?
Whether it's an easement or could it be developed?
Right. Could it be developed? Who owns it? Who owns that parcel? And with our PG Atlas software, you can go in there and find out who owns it. It might be, and what are you seeing that's really weird? It comes up through, so you're seeing where the stream is, right? Did you catch the stream over here? With those contours pointing up? So which way does that stream flow? North to south or south to north? North to south is how it flows, right? You down with that? So it's coming this way. This stream is. So this parcel right here is a very weird shape. It's narrow. It comes in like that. That's what Adam was saying. Is there an easement or, like what's going on there? So you'd really want to know what was up with that parcel. It could be even, like an abandoned road right away. Those kind of things. Well, I tell you, when we were looking for a house, it helped to have these skills so much because I was always asking, is there an easement there? Well, how does that? I looked at an aerial, I thought there was a dump near our house. I was like, oh no, this is a perfect house, and then it's a rock quarry. Doesn't mean there's not some externalities, but way different than a dump, right? So you gotta, doing this pre-research. Okay, yeah, so are you concerned at all about the practices or uses of other properties? Sounded like you were. So if that mound gets developed, that property, that could be bad. Could increase the amount of runoff coming down there. Could not be a really good thing for that. So what would you say you wanted to do some rain gardens, some stormwater kinds of things on this property? And when you go to do your site visit, where would you walk around not on this property? I mean, might you walk down to this stream and go, I wonder what's growing in that stream? What can I replicate up on our site to do the same thing? Is there something there that I can, what's the plant community? That's the term that the other instructors in the program use a lot. What are the plant communities that I can, mimic or replicate in our design? Yeah. The other thing is, so you're seeing these, like that says P43, and a couple of these are letters. I'm not seeing a good one, but there's, here, like this is P period D period. And I don't know what that letter is, but it's P period something. Those are, when it's a P and a number, it means parcel. So it'll say like parcel 24. That's usually, this is a rule of thumb, a buildable lot if it's got a number. If it's got a letter, and this is a Bowie, so all this subdivision was done all at the same time, all the plats were laid out, all of the land, was subdivided all at one time. So the lettered parcels are usually what are called out parcels, or public land, or something that's not developable if it has a letter. So that gives you a little bit of clue when you're looking at, these maps and you go, oh, that's a letter parcel. I should look at that. Maybe that's public land. And if you think about it, so here's all these houses. I didn't see what this looks like on the aerial. Is this a park?
They're trees.
Oh, it's just trees. Well, a lot of what they did in Bowie was they made sure when they designed the subdivisions that everybody had access to the open space. Look at that open space parcel there and all the ways that you can get into it. You can come off of this street and there's this skinny piece that you can walk up. You can walk up through this connection here, this connection, this connection. Oops, there's no one. Or is that a lot? I can't tell. Anyway, they did a lot of these open space pieces in people's backyards and then made sure there was access to them that was public. Very, good aspect of that kind of design. Okay, let's talk about Lot B. Oh, your spouse saw this lot and they said, oh my gosh, we've got to have this house. It's It's my dream house. Look at this kitchen. Oh my gosh, best kitchen there ever was. And then you start looking at the drainage. So same questions. Where is the offsite water coming to onto lot B? South to north, east to west, west to east.
Coming from the north.
Coming from the north? Okay. Is it coming from off the lots or the road?
The road's
or-
coming from the road. The roads,
Okay.
unless you've got some drainage going on.
Yeah, so it's coming down the road. Where's the high point on that road? Is the whole road draining there, or is there a high point? Remember when we did our big watershed delineations and you came across two roads that had a high point?
I think the high point is right at the intersection of Amberley Court and, right there at the.
Not really. Where's the high point, I'm sorry if I wasn't clear, on Heatherstone Drive, where's the high point north? You said that water was coming down Heatherstone Drive, okay? Do you see where the high point is?
Close to the top.
Right up at the top, right.
It's a
These
downhill.
contours are circling back on themselves, so that's the high point there. So this street is carrying water. What? Right
There's
down the hill.
another- like, this is also 160. Like this line right here.
Oh, and that's,
So-
and that's 160
And
up
that's
there too?
160 up here.
Okay, so
this
that's a
would go
little flat
that way,
spot.
right?
Very
This would
good.
be,
Right, so it's not, doesn't come up quite so far. These are hard to read up here. Yeah, so right about here. And this is all running that direction. If I just, we looked for houses on the computer, just, whatever we could pull up, Google Earth, whatever. This is what you do when you start out doing a project, is you go online, see what you can find. And, this is something that if you didn't know how to read the topo lines, you might not know to look for when you go out there. Okay, it's getting water from another direction too.
what's the east?
From the east sidewards, yeah.
But
Over West
I
Seventh.
heard west to east. Is it coming down Amberley Court? Yeah. Are you seeing that?
Yeah.
Hold on, let's stick with one at a time. So are you seeing that it's coming down Amberley Court? Because these contours are pointing up. Are you getting that? They're pointing upstream. So that's why the flow is down. Okay, so this is going this way. Now granted, there might be a whole bunch of stormwater inlets along there, but it's, for a road, it's pretty steep. So water can bypass those inlets quite easily. My mother's house in Illinois never flooded for all the time we lived there. They bought it in 1969, until they developed across the street. And then, and it was very funny. I love the Farmer's Almanac. You buy the Farmer's Almanac. It's just fun and interesting little facts. I was in there looking at it one day. It's like, oh, this is the date of the flood in Aurora, Illinois. Epic flood. It rained 17